Hi, welcome. Today I would like to talk about how you can use the Windows C low-level API to do synchronization and create threads. So let's get started. So let me just kind of walk you through the code and then I'll give you the demo. So basically I have a C function here and I'm initializing a global counter to 0 and I give something to a worker function or a thread, several threads. And this is a pointer to a function called inc. So let me just show you this function first so you can kind of get an idea of what it is. So essentially this is the signature I'm using because if you want to be able to call uh, from a thread start a function in a low level Windows, you need to be able to set this particular signature function. And it's pretty straightforward. So all I'm doing here is essentially going through a loop and I have set this count value to be 10 and I'm incrementing this counter and I sleep for 10 milliseconds. And at the end of this function, I return 1. And let me just show you what this worker function does. And let's just go over there. Basically, it takes this routine which it is going to call. So you can see its routine is being called here and it's going to call and create a number of threads and it's going to use the Win32 API. It's called create thread and the thread count is 10. So you can see it is incrementing, it's using 10 threads and for each time of the function call it's incrementing by 10. So we should get about 100 if it all works. Here is essentially where I'm storing the thread handles. So it does a create thread call. Here is the function it is given. And this is an error case which probably won't happen. So it shouldn't be no problem. And then wait here for all the threads to complete and and at the end of it I just close all the handles. So if I go back to the function, the first function was inc. You saw it here. It basically has no synchronization. It just implements the counter, and the reason I have it so you can see that even though we are incrementing in each thread something count by 10, we are not going to get 100 after the result is done. After this, I'm going to show you some of the simple interlock increment that you can use to do synchronization. And this is a call called interlocked increment. And it basically allows you to increment a variable or some other things in just in a very in a manner which is essentially cannot be blocked by anything else. So this would work and it increments the counter. If you have to do something simple like just incrementing a counter, you could just use this synchronization primitive called interlocked increment. If you wanted to go a little bit more after that, I'm using what is called the critical section, and I'm going to show you how to do the critical section increment. Basically, to do that, I have a routine called critical section init, and then I use all the critical sections in this worker threads, and then I close the critical section. If you look at my critical section increment function, it's pretty straightforward. What we do is we enter a critical section and give it a critical section handle, and here's a critical section handle. And when we are done with incrementing and sleeping, we leave the critical section. To initialize the critical section, there is a call initialize critical section. And to delete is closing the critical section. So that should work as well. And the thing about the critical section is that it works for one process. So if in one process you have several threads, this would work fine. So if you wanted to have synchronization among different processes, what you may want to do is go to something called the name mutexes. And I'm going to show you how to do that. And here is the call. I'm doing the mutex increment, so the same thing, but I'm doing it using the name mutexes. So first thing you want to do is when you initialize the mutex, want to create the mutex, you can give a call something like this, where basically say I'm not owning the mutex and the name of the mutex is my mutex. When you close, you want to close the handle for the mutex, you declare the handle mutex like this. And incrementing, we are basically waiting for the single object and we are infiniting, going to timeout infinite. And then we do this and release the mutex. So if you look at these functions, basically all of these should be working. And now if I run this, you can see the results. So this first case was the case where we didn't have any synchronization primitive so that we expected not to be 100, and it's actually in this test case is just 92. And all of this counters synchronization primitives works because I just told you how to use three different synchronization primitives for Windows. So thank you for watching this short screencast, and you have a great day.